So in problem 1.8, we consider a case where you borrow 1,000, which you will pay back over the next 10 years by paying 100 back each year from the beginning of next year. So let's try to draw up that payment stream. So from the beginning of next year, the first year, so at time 0, we borrow the money, right? And then at the beginning of next year, you'll pay back 100. And then the year after, you pay back another 100, and so on, until all 10 years are gone and you've paid back the whole amount you've borrowed. Now, it's never really free to borrow money in this world, so you also have to pay an interest. And how does that work? How does the interest part work? Well, it works like this. At time 0, so let me just draw 1, 2, and then here we have 9, 10. At time 0, how much do you have left to pay back of the loan? Well, at time 0, you've just borrowed the 1,000, so you have 1,000 left. That means during this year here, you have 1,000 at your disposal. So you will have to pay 4% times 1,000. You will have to pay 4% times 1,000 at this time point in interest, because you had this 1,000 at your disposal during this year. Now, at time 1, you pay back 100 of the loan, so you have 900 at your disposal during this year, which means at point 2, at time point 2, you have to pay 4% multiplied by 900 in interest. And that's how it goes on until the end of year 8 and the beginning of year 9. And how does this thing look then? Well, at the beginning of year 9, you have just paid 100 more, sorry, not 800 here. You have just paid 100 more back of the remaining 200 that you have loaned. So here you pay another 4% interest of the amount of 200 that was left from year 8. And then you have 100 left, and because you have 100 at your disposal during this time period, at time 10, you have to pay 4% multiplied by 100 at time 10. So how much do you pay in interest all in all? Well, now this gets a bit tricky, because can we just say that we add these numbers up? That's not really what we've been doing in this course up until now, because time value of money does exist. So we can try to write up what we are actually looking at when we answer the question, how much do you totally pay in interest during this period? Well, the amount we totally pay in interest during this period is, it kind of depends, right? Are we looking here? Do we mean how much is the initial present value of what we totally pay in interest? Or do we mean how much is the terminal present value of what we pay in interest? Sort of depends. So we should specify in the answer of our exercise where we choose to sum our money, at which time point we choose to sum our money. And what we do here, what I like to do normally, is to talk about the initial present value, because then I can stand at time 0 and think about, well, if I borrow this 1,000, then I will need to pay all in all what corresponds to X amount of money in present time value in interest in the future. So let's try to do that. So the initial present value of total interest paid over these 10 years is given by the sum of, well, let's just try to write the numbers out first, is given by 0.04 multiplied by 1,000, and then we discount that one period, right? so multiplied by 1000, and then multiplied by v to the first, plus 0.04 multiplied by 900, which is discounted 2 time periods, so v to the v to the second, and plus etc., 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 until we have the last interest payment, which is 0.04 multiplied by 100 multiplied by the discount factor for 10 years, like that. And we can see that all of these terms have the interest 0.04 in common. And they actually also have a 100 in common that we can multiply outside of all of these terms. So what we have left inside these terms is, well, we have v to the first, second, and so on to the 10th. So we have something like k equal to 1, 2, 3, 4, etc. up to 10, right? And we multiply that by 1000, well, not 1000 anymore because I've taken 100 outside of the parentheses. So we multiply that by 10 minus, well, k plus minus k minus 1. In the sense that when we have v to the first, I want to multiply v to the first with 10. So k is equal to 1, and that gives me 10 minus 0. And when I have v to the second, I want to multiply it with 9. So 9 minus 2 minus 1 is, 10 minus 2 minus 1 is equal to 10 minus 1, which is equal to 9. So this is the formula for the initial present value of the total interest that is paid over 10 years. And let me try and see if I can't write that a bit nicer. So I can get these two together. So we have 4 multiplied by, and then we have the sum, and it's just a bit nicer to have the plus 1 minus 1 stuff up here. So I can actually change this to k equal to 0 up to 10, because then I can just have 10 minus k, and then I have v to the k plus 1, like that. Okay, so this is the final answer that I would propose for this exercise, and you can just try to plug in 4% in the place of I, and oh, sorry, not up to 10. It goes up to 9 up here because we've switched the indices. We've translated the index by minus 1. So then you can also try to plug in the I and then see what goes on. There is also a more crude way of doing this where we just say, well, let's just add these numbers together, in which case you just have 0.04 multiplied by the sum of k going from 0 to 9 of 1000 minus k times 100. And in that case, the answer would be 220, quite simply. But personally, I think if you have to add numbers together, it's a better idea to add them in the sense that you actually discount them all back to the same time period, time point. And that was problem 1A. We only spent one video doing that. If you have any questions, just drop by with an email or something.